So now let's talk about Thevenin's theorem and how to use it in circuit analysis. So now let's do the example when we need to apply Thevenin theorem to find current I. The current I is the current through 1 ohm resistor, and that resistor is also known as the load resistor, so we can call it our load. And pretty much we're not going to touch this resistor, but what we can do, the idea of Thevenin theorem, that the rest of the circuit between terminals A and B connected to the load, to 1 ohm resistor, could be replaced by two equivalent parameters, equivalent voltage and equivalent resistance. So pretty much the rest of the circuit could be replaced by voltage, Thevenin voltage source, so here we go, plus minus Thevenin, connected in series to the equivalent resistance, called as Thevenin, RTH. So this is our open circuit to terminals A and B, and as we had originally, A and B is connected to 1 ohm resistor, so the 1 ohm resistor will be placed in between. And this is our Thevenin circuit, equivalent circuit, where it is much easier to find, for example, the current I, so 1 ohm resistor, or if required, we can easily find the voltage across this 1 ohm resistor. So let's start finding Thevenin equivalent, and we need to find Thevenin and Thevenin. First of all, we need to remove the load, because the equivalent is the equivalent at an open circuit between A and B. So once it's done, we can start looking on the equivalent resistance, Thevenin. So this will be our first step to find RTH or Thevenin. So how to do this? How to find Thevenin? We need to remove all independent power sources and find equivalent resistance in the circuit. In our case, there are two power sources, independent power sources, is 12 volts and 2 amps. So once we turned off independent power sources, we'll create the new circuit, and it is probably a good idea to draw it. So what do we have? When we remove voltage source, we're creating a short circuit. So we have a 6 ohms resistor. This is 6 ohms resistor. Looking into 2 amps power source, if we switch it on, we create an open circuit, so pretty much we're not going to put any wire here. Continue by the next 6 ohm resistor, and we also have 4 ohms. And the question is, that this is very important, that we need to find equivalent resistance, Thevenin, looking into terminals A and B. So don't forget, this is the place where we need to find the equivalent resistance, A and B. So pretty much you need to look into this way from the right to find RTH, Thevenin. So this is the circuit, and what would be the equivalent resistance RTH in this case? We can see that 4 ohm resistor is connected in parallel to 6 ohms resistor. So 4 is in parallel to what? To 6 plus 6, because these two resistors are in series. So 4 in parallel to 6 plus 6. And RTH will be 4 times 12 over 4 plus 12, which is equal to 3. So I just write it on the top because we already found the first parameter, the first equivalent parameter, as equivalent resistance. So equivalent resistance, Thevenin resistance, is 3 ohms. Now the next step is to find Thevenin voltage, VTH, and in this case we need to come back to our original circuit, open circuit, and the Thevenin voltage is the equivalent voltage between terminals A and B. So here plus and minus, and this is the place where we need to find VThevenin and VTH. Looking into the circuit, we can see that VTH is the same as the voltage across 4 ohms resistor, so across this branch, and that means that this voltage is the same as the voltage on this upper node. Let's call it V2. Again, looking into the circuit, it looks like we have 2 nodes, and it's more likely that we'll be using nodal analysis to find V2. So let's name the first node as V1, the second node as V2, and like I said, VThevenin is the same as the voltage V2. So to find voltage V2, we need to write 2 nodal equations. So let's do this. For node 1, what do we have? The first current is coming in due to 12 volts. So we have 12 minus V1 over 6. Then 2 amps coming in. So we put plus 2. And then the current from V1 to V2 going this way. Out from the node. So we put minus V1 minus V2 over 6 and equals 0. So this is the equation for node 1. Let's do the same for node 2. So the second nodal equation for node 2, we have the current coming in from 6 ohm resistor, so that will be V1 minus V2 over 6. Now it is positive because it's coming in, and just one more current through 4 ohms resistor, it's going out, so we put minus V2 over 4. Equations, solving, we can find the nodal voltage V2, which is equal to 6 volts. Like pretty much when you solve these 2 equations, we don't worry about V1 because this is not a part of the question. We only need to know the value of voltage V2, and that means that Thevenin is the same as V2, and that will be 6 volts. So just gonna write it on the top. So we found Thevenin resistance, and now we found Thevenin voltage, which is equal to 6 volts. So now let's see what we can do with these 2 equivalent parameters as RThevenin and VThevenin. First of all, what was the question? The question was to find current I, and this current was the current through the load, 1 ohm resistor. So if we place the resistor back, and that resistor was exactly across A and B, so here we used to have 1 ohm resistor, and the current I is the current flowing through that resistor. But because we already found RThevenin and VThevenin, we can replace the original circuit by the Thevenin circuit, where we have the Thevenin voltage 6 volts plus minus 6 volts connected in series to Thevenin resistance, and that we found to be 3 ohms. So this is the open circuit between A and B, and the load resistor, 1 ohm resistor, was connected exactly across the circuit. So between A and B we can place the 1 ohm resistor. So here our equivalent circuit, and now it is pretty easy to find current I, the current through 1 ohm resistor. How to do this? We can see that we have 2 resistors, 3 ohms and 1 ohm, connected in series. So the current in 1 ohm resistor will be, using Ohm's law, current I will be the total voltage, which is 6 volts, over the total resistance. And the total resistance for 2 resistors in series will be 3 plus 1. And the answer for the current will be 1.5 amps.